Bright Duty. Every student matters.
Let's move on to these two problems. The first problem is corrosion. Now what happens in corrosion? In corrosion, a metal, any metal, reacts with the air, with the moisture or with the acids present on its surface and forms a layer which weakens the metal. So what we will do is place the brightly polished iron nail along with fused calcium chloride in the test tube A and plug it with help of a cork. So in this we have will be our test tube A. The fused calcium chloride keeps the air in the test tube dry as it absorbs all the moisture from the air. So here we do not have moisture. In the second one, place the nail in the test tube B and pour boiled water in it. The boiled water does not contain any dissolved air because of the boiling process. And now pour 1 cc of kerosene oil, which does not allow the atmospheric air to come in contact with the boiled water, and plug it again with a cork. Now place the third brightly polished nail in test tube C and pour 5 cc of tap water in it. Plug the test tube mouth with a cork and leave all the test tubes undisturbed for 3 days. So we have 3 test tubes, one without air, we have one without water, and we have one with tap water. You will observe that the nails in test tube A and test tube B do not rust. Thus, we can conclude that dry air and only water do not promote rusting. Now observe the test tube C. You find that the nail in the tube has started rusting. Thus, we can conclude that air as well as moisture together only promote rusting. So, from this activity, we have been able to understand that for the process of rusting, we require two components, air and water. Air alone or water alone will not be able to promote rusting. Only when the both of them are present, then rusting happens. In test tube A, we saw in the absence of water, rusting did not happen. In the test tube B, in the absence of air, rusting did not happen. So when both conditions were present, then only rusting happened. So for rusting, we require both air and water. You must have seen if your bicycle was kept outside for too long, then it so happens that it develops a rusty layer. Rust is actually a reddish brown substance on its covering, which is actually rust is iron oxide. So iron develops rust, which is reddish brown. Same happens for other substances also, like silver develops a black colored layer of sulfide on it, and copper develops a green colored layer of carbonate on it. So when a metal reacts with air, moisture or acids present on its surface and forms this covering of rust or other kinds of degenerations, then it is called as corrosion. Corrosion is very harmful to the metal because it weakens the metal. The metal loses its initial properties and it becomes weak. If, for example, a ship or a car or a aircraft loses its properties of metal, then it can be very dangerous. So that is the problems and the loss that we have to face because of this feature of corrosion. There are some preventive techniques as well. First preventive techniques is painting. When we paint a metal, what happens is that the surface is unable to get in contact with either air or moisture or acids. Because all of them are cut off from the metal, it so happens that the metal is safer. That is why all the cars, all the bicycles are painted to increase the length of the life of the metal. Second is polishing. You must have seen either a layer of polish or grease applied over chains or different parts of the housing, like where the door opens and all those places. That polishing or greasing is done so that the metal does not come in contact with the air and the moisture and does not form rust or any other form of corrosion. Last type of prevention is galvanization. Galvanization is done when a metal is of extreme importance, like in case of aircrafts or ships, where even painting or polishing could come off, and that could be very dangerous. So the metal is covered with a layer of another metal of zinc. As we saw previously, that zinc is very reactive, very little reactive, and so zinc does not react with the air. And even if zinc does react, the metal inside is still safe, and that is how the element's safety is ensured. So what we studied in corrosion was that corrosion is the deterioration of a metal by reacting with air, moisture and acid present on its surface. It can cause a great deal of loss if it harms the cars, ships, airplanes, etc., because it weakens the metal's strength. And to prevent it, we can use painting, we can use polishing, and we can use galvanization amongst other techniques to reduce the harm. The last problem that we will be studying is of rancidity. Rancidity is again a new topic, not related to the previous topics, but it is related to redox reaction. So what happens is, when a food item is kept out and it has fats in it, anything which is fatty like chips, when they're kept out for too long, the fat reacts with the air and it gets oxidized. Because of the oxidation of food, there is a damaging effect on food. The food now tastes bad, smells bad, and has a different texture. That food can be very injurious if consumed by the person. So that is why rancid food items can cause a lot of diseases also. To prevent rancidity, what do? We cannot always eat fresh food, so there are three ways of preventing rancidity in packed foods. First is nitrogen flushing. So if you receive a packet of Lay's or any of the chips from a brand, they are sealed and flushed with nitrogen. That is why the packet is so fluffy. They're flushed with nitrogen because nitrogen is an inert gas. It does not react with anything. It prevents the food items also from reacting with the air, and that is why the food item is crispy when it comes out. Next is antioxidants. Sometimes nitrogen cannot be used in other items, then we use other kinds of antioxidants which prevent the food from reacting with the air. Last is airtight containers. So if at home somebody wants to keep some food and they do not have nitrogen or antioxidants there, then what they do is they use some airtight containers so that when the air is unable to come inside, it will not be able to react with the food. So that is all about rancidity. In this part, we discussed what was reduction, what was oxidation, how they commonly occur to form redox reaction together. In redox reaction, we discussed what is reduction, which element is getting reduced, which element is getting oxidized, what is the oxidizing agent, what is the reducing agent, and then we studied two applications of chemical reactions, which are corrosion and rancidity. In corrosion, metals are harmed, and we studied the ways to prevent it. And in rancidity, it is about damaging effect on oxidation of fatty food, and we can prevent it by three methods: nitrogen flushing, antioxidants, and airtight containers. That's all for this chapter. Thank you.